Hello everyone and welcome to yet another repair video on a home audio device. This time it's the Onkyo AV Receiver TX-DS575, and I found out that this is quite a popular receiver. Many people use it, many people have it at home, and as many old receivers this develops some problems over time. So in this video I'm going to explain you how you can possibly repair two of the main problems that this unit develops. So the first one is, most common one, there is just no sound anymore coming from the speakers, or the sound is intermittent, or the sound is very dim, or it cuts out at times. This might happen at all speakers at once or just at one or two channels, for example. So this is the main problem we're going to address within this video, and then there's a second which concerns this digital voltage control knob. And what sometimes happens, not with this unit I have here, but with other units, is it sometimes glitches. So for example, when you continue turning it into one direction, it will suddenly jump back to +20 and then down again. So as I said, this unit doesn't have this problem, this unit works fine, but still I'm going to tell you how you could repair your unit if you have this fault with your unit.
So one thing you might want to check before you go into this repair is to check whether it's maybe just a software problem you're having. And you can do that by completely resetting all the settings of this receiver by pressing the video 1 button at the same time as the speaker A button while the amplifier is powered on. And when you do that, you can see the message clear coming up on the screen. And now all the settings are back to the factory default. So you can do that, and maybe now your problem is already gone, then you were in luck and it was just a software issue. If this didn't resolve your problem, then you can continue with the actual repair shown here.
So before we start the repair, what you're going to do is you're going to turn the unit off. And you're also going to unplug the mains cord. Be sure to do that before you actually start the repair. And then what I also would recommend is that you just let the receiver sit down unpowered with the cord unplugged for at least some hours, even better for 1 or 2 days, because inside there are quite large filter capacitors that can hold a lot of charge even for a very long time. So even after you unplug the power cord, just leave it sitting for a while. After that you should be fine, there shouldn't be any harmful voltages inside, but still you do this repair at your own risk. I'm just going to give you some information here, what you would need to do. It's completely up to you what you do with this information. If you don't feel comfortable enough to do a repair like this, leave it be. As I said, whatever you do at your own risk. So let's get started. Before you can actually do anything, you need to unscrew the, I think it's 7 screws of the case. So there are 2 on the right side, 3 on the top of the back cover, and 2 on the left side. I already undid these screws. And then you're gonna lift the whole top cover up. So first slide it in a little angle like this, and then completely lift it off. And once you've done that, you can see inside the inner of the amplifier. So the first thing I'm going to do is I'm going to repair the thing that there is no sound. And this is usually caused by faulty output relays or bad output relays. You will find that in this amplifier there are a couple of relays, actually 4 of them. So right in here you see this black box buried underneath all the cables. This is the relay that switches the front left and front right speaker. And then over on this board there are 2 more relays of the same size, one up here and the other down there. And there is another white relay here, and this white one is just for switching the center speaker. So what we need to do is we have to get the boards out that these relays actually sit on, to unsolder them and replace them with new good relays. So one of the first things we need to do when we want to replace these relays is we have to get the boards loose that the relays sit on. And for that we start at the back of the unit. And we will first remove the 2 screws holding in these speaker connectors and also the 2 screws holding in these connectors. And then what you also want to do now is undo the 2 screws sitting in these little retents, because they hold in the whole cooling block that we actually need to remove to get to the boards.
And then you're going to continue, unscrew the two screws here at the kinched connectors, these two at the S-video connectors, and also the 3 ones next to the composite video connectors. So now we return to the actual inner parts of this amplifier. And it's going to be a little tricky to get to the relays because, as I said, you have to remove all this cooling block and the amplifier boards will come out with it. And in order to do that, you will first have to get rid of all the cabling that goes over this section. So what I would recommend is just start to get in there with a side cutter and undo all the cable ties that hold the cables on top of this cooling block. Of course, be sure not to cut the cables, just cut the cable ties. Okay, so this should be it. And now some of the cables you can actually undo because they are just plugged in. For example, these you can just unplug, move them away. Or this over here on the power board is also just connected. These connectors are a little weird because you have to push them down and then you can just undo the cable and you just end up with the loose ends of the cable. And the same thing goes for all the connectors that go to the amplifier board on this side. Luckily they all have a different number of pins, so when you want to redo the connections, you know which is which. So now we are more or less free of the cables, except some that go to the main amplifier board on the other side. These you will just have to bend over like this. And then on the left side there are even more cable ties you have to get rid of. One of them is on top of this card. Another one is holding all the cables down here together. Now you can already see that things start to get loose. So what we want to do is to get a little more room and to be able to get this whole amplifier section out, we will also have to get rid of this card, which is, I think, the video distribution card, which is connected to another card, the S-video input-output card. So this is why we had to undo all the screws on the back for these cards. And now, once all the screws are off and all the cable ties are cut, you should be able to lift this card up. It's just plugged to the main board, so with some force it should actually just come out. Doesn't sound nice, but it works. And then you can pull the whole section off. Now you'll find that there's another cable that is going to the treble and bass control on the front, which is also connected via a cable tie. So undo this as well, unplug the power cable from the front connectors, and then you can finally get this whole board out. You don't really need to do anything with this, you just need to get it out to access the amplifier section, which we can now see down there. So there is another connector that you have to remove to get this section off. You can see it in there, it's connecting this board to this board, and it's actually just plugged in. Just grab the left part of it with 2 fingers and then just raise it up until it comes off of its socket. Then right here at the back of the unit there is this blue connector, which you don't actually have to remove. This is just connecting to the 5-channel input card that we also unscrewed. You can just take it like this and just place it here so it won't get stuck above the amplifier section. This cable you can also now bend away. And now you're almost ready. But there's something more that we need to unscrew first. And what I just did is I just turned the unit around, because there are 2 screws on the other side of the cooling fins, which are actually right down here and on the other side. Don't know if you can see it this way. Yeah, so one of the screws is right there and there's a matching one on the other side. So now the whole amplifier section along with the cooler is almost free, but you will find that there are some more of these plastic retention clips that hold the board in still. And to undo these things, you just take a pair of flat-headed pliers, just push the head together and then try to force the board up. And then it will usually stay on top of this retention thing. And then repeat the process for every other of these things. So this is 2 of them, and then there is a 3rd one right here in front of the blue connector. I think it's the last one in here. Yeah, so as you saw, these things can be a little painful, but now this board is loose, and you should now feel that the whole section is actually loose. So I would recommend to just grab this thing on the cooling section, because this is quite rugged, and then gently lift it off. So pull it a little to the back first, or to, in this case, the front of the unit, to get it out of some retention slots here at the back. And once it's out of that, you can try to gently pull it to the top. Always make sure that no cables are in the way. So the thing is, this section is still not completely disconnected, since the wires to the mains transformer are hard soldered, so they are still on. So you will not be able to pull this completely away from the case, but you will be able to lift it out, and this is what we want. So this is, as you see, not an easy process, but when you removed all the screws and connections that you could remove, you will somehow be able to maneuver it out of there. And there you go. So as you see, there is still a cable connecting to the mains transformer, but this doesn't really matter so much for us. So now we have this amplifier section out, and we can actually start replacing the relays. I usually start replacing just this relay because it's on its own. Again, this is a cable that is not just plugged, it's actually hard soldered. So what I usually do is to just leave the board as it is and just solder like right on here. So first what I'm going to do is I'm just going to unsolder this relay here. And what I'm also going to do is I'm going to unsolder the diode next to it. And I'm going to explain why in a minute. So let's get the soldering iron and get this relay off first. And the way I usually desolder stuff like this is to first apply some new solder to all the pins, to just have it flowing a little better, to make it easier to remove afterwards. So I'm going to apply a little of solder to all the pins of the relay and also to the pins of the diode, as I said. So once this is done, you can start with whatever tool you like. I usually use this solder sucker. And now once you've actually desoldered all the pins from the relay, you should just be able to pull it off the PCB. There you go. If it doesn't work right away, just move it a little back and forth. So, and as I said, this is a 24-volt relay with 2 independent closing contacts. And you might be able to get an exact replacement at your local reseller. Unfortunately, I wasn't able to do so. So what I use instead is this Finder relay. I will link it in down below. But the problem with this is they have the same footprint, so 5mm and 10mm spacing and everything. But if you line up the coils of these two relays, the actual 2 contacts that go in the holes of the old relay would be the normally closed ones, but you need the normally open ones to be there. So we have to get a little creative here. So what I usually do is I bend these 2 pins 2.5mm to this direction, then the 2 outer pairs of pins 2.5mm to the other side, and I'm going to cut these 2 off because you don't need the normally closed contacts. And I usually use again this flathead pair of pliers. Just put it at a height and then just go a little like this. And then I end up with a pin that's obviously shorter, but it's still able to penetrate the PCB, and it's now shifted more or less 2.5 millimeters to this side. I'm going to repeat this procedure for the other pins, and then I'm going to show you the result. And when you now take a look at these two relays, this one with the bent pins, you can see that the footprints actually now exactly match up, and the length of the pins is still sufficient, as I said, to penetrate the PCB later on. But now you will run into another problem. I don't know if you are able to see that, but the holes for the actual power contacts are a little larger than these holes. But on the replacement relays, all the pins are the same size. So you need to widen up these holes a little. And what I usually do is I just take a Torx screwdriver that is not too worthy to me, and I just go like a drill and just give it some turns until you actually penetrate the PCB. And usually you should do this from the underside, because then chances are lower that you're going to ruin the solder. And now once you've done that, you should finally be able to inject the relay into the new PCB. But now you find yet another problem, which is this diode here, because now since the actual outline of the case of this relay is larger, this diode won't fit anymore where it now is. So this is why I desoldered this as well. So first thing you need to do is you need to remember how the positioning of the diode is. So in this case the yellow ring is at the D of the D591 marking here. So just take it out for the moment, put it somewhere safe, and try to get the relay in. Since the contacts are bent, they will most likely not fit in the first attempt, but then just move it around a little bit, and eventually you will end up with all the contacts fitting. And now you see that still, even if they are bent, there is some length that actually penetrates the PCB and that you can now solder to. Just make sure that the 4 contacts that actually conduct the current to the speakers have solid contact and are soldered properly. The other 2 ones don't matter that much. Now the last thing we need to do here is just reattach the diode. And I would just attach it at the bottom now, which is not easy to do in manufacturing, but now in this case it's more or less the same. So again, remember the orientation, the yellow ring now to the right, to the D symbol of the marking. Just stick it in from the bottom like so, make sure it won't come out. So again, the orientation here is crucial. I don't know if you can see it, but the yellow ring has to be on this side of the diode. Then you can just solder it in like this. And then this board is all done with the new relay in place. So you might ask yourself if it's now still safe to use, since this relay has bent contacts and isn't as stable as the original one. Well, as long as you don't plan to ship this unit a lot or to have it shaken around all the time, if it just sits on some bench, it's completely fine. And even if you are to transport it, I personally cannot imagine this being a problem, since still with 6 contacts soldered, this thing is pretty solid. So now we have to go over to the other 3 relays on the other side. So I've turned the whole amplifier section around, as you can see. And to proceed now, what you will need to do is you have to unscrew the whole PCB from the cooling. This includes 6 screws that hold the transistors in and 3 more screws that hold the thermal diodes in. So just unscrew all these and then you should be able to take the whole PCB off. But be aware there's some thermal interface material, so some thermal compound beneath that's a little sticky. So the PCB won't come off right away, but you have to move it a little until it comes loose. So now once you remove the screws from all the components, and also 3 more screws I forget to mention that hold the PCB onto the metal, you can now gently start with a little movement to the side, try to get this whole thing off, and eventually you'll see another screw in here. And if you take that off as well, then your PCB is finally free. Now be careful not to touch these, because the thermal compound is quite sticky and it's quite hard to get out of fabric and stuff. So now we can finally put all the casing and the cooling aside and then just work on the PCB. So in this case I would recommend to renew the thermal compound. So what I'm going to do here is I'm going to take a piece of paper and then just gently remove the leftover thermal compound of the transistors. You can put them back with the same old thermal compound, but as I said, if you have thermal compound, I would strongly recommend to renew it to just get a better thermal performance, to keep the transistors cool. This way they will last a lot longer. Make sure not to put too much pressure on the devices, since they are not soldered directly on the PCB, but instead they are standing off by quite some amount. So you don't want to put too much force on the pins to actually bend them. So I will call this clean enough. And what's now left to do is to replace the 3 relays on this board. To remember you, these 2 ones are again the same as before. We have to bend the leads. This one is different and it has only 1 closing contact. I will also provide a replacement part which actually this time has the exact correct footprint to replace it. For these, the reason I also chose the replacement parts I did is because they're relatively cheap. I can get these relays for less than €3 a piece. So I didn't actually bother to go in and try to find the exact same replacement part with the correct footprint. And again, we have to remove the diodes as well. There's one down here and the other above the other relay here. This one is pointing this direction, so it has the yellow ring on this side. The one down here has the ring to this side. So same as before, just apply some new fresh solder to all the relay pins. And then just go in and remove them all, including the 2 diodes next to the 2 black relays. And then once again, you should be able to just pull these relays out with relative ease. Then I will go in now and widen the holes for the coils a little more. So this is a technique I have to use relatively often, since most of the standard relays have these smaller contacts for the coils. And most of the replacements you get have the same bigger size for the pins of the coils. It's of course not a nice thing to do to the PCB, but since it's just related to the pins of the coil, which will run almost no current, like 5 to 8 milliamps, it's really not such a big deal and will not be a problem in the normal use case. Now I will turn around the diodes right away so I don't forget the orientation. So when you now place the 2 diodes on this side of the PCB now, again make sure to put them in the right orientation. So the ring of this one has to be where I solder now, so on the outer side of the board. And on the other diode, the yellow ring is now here, so on the inner side of the board. And then you're good to go in that respect. So now again you have to take 2 more of these 24-volt relays and bend the pins as I shown before, which I will do now off camera. So now, as you can see here, 2 more relays with the pins bent. And when you do this technique the first time, we recommend you to buy 1 or 2 more spare relays in case you completely break one of the pins. They don't look perfect and are not perfectly aligned, but once you try to actually put them into the PCB, they will more or less align themselves. So now once you put the relays in, you should see each of the pins penetrating the PCB at least a little bit. If that's not the case, give them a little more force to push them in.
And when you're done, just solder every leg of the relay on. So these are these two relays. I won't show you the same process for the other smaller relay here, since it's basically the same and you don't even have to change the diode, because in this case the actual outline of the pins matches up the original perfectly. So now you're also done with this PCB and you can reattach it to the cooling block. So before you reattach the PCB and all the transistors back to the cooling block, one more word on this thermal interface material. So when you look closely at these, there's not only the thermal interface material, it's coming out to the sides, but there is also an insulation pad on each of the transistors, since its metal base has to be isolated from the cooling and you don't want to remove that. So if you want to go in there and then just remove the excess of the thermal interface material that's like on top and leaking out the sides of the insulation pad, but try not to move the pad itself. If you did accidentally, you can always line it up back later to the screw hole in the middle. And as I said, you don't have to get this clean to any extent, just get the excess solder, the excess thermal interface material off. Just like this. As I said, not pretty, but I will call this clean enough. And what you're then going to do, you're going to take new thermal interface material. You can use regular one, what you'd also use for your CPU and your PC or whatever. And then just add like one little drop of that to every of the 6 transistors. And then you end up with something looking, for example, like this. You don't have to distribute this thermal paste. It will distribute itself once you actually screw it on by the force of the screws. So now you can start to align this PCB. Again, I would start by aligning just the outer screw holes to the metal part. And once the transistors actually make contact, it will get reasonably sticky. And then you can start with one of the screws. These on the sides are not the longer black ones, but it's the shorter ones. And screw this one in, not tighten it up yet, just screw it in so it will keep the board from floating away. Then do at least one of the same on the other side. And now, as you can see, the board basically stays leveled. And what you want to do now is you want to insert the total 9 screws that actually cool devices to make sure that the alignment is correct. Again, don't tighten them up yet, just make sure that the screw hole lines up with the device. Repeat that for every of the 6 transistors and 3 diodes. Once this is done, don't forget to put in the other 2 screws that hold the metal parts on. So one more on this side. And the last one I initially forgot on the center of the PCB. And then start by tightening up these 4 screws so that the actual force that's holding the PCB in will lie on these screws and not on the screws that hold in the actual power devices. So then afterwards, after you tightened up these 4 screws, you can go in there and tighten up all the screws that hold the actual devices in, since now the board won't move anymore and you're good to go. You should have a feeling yourself how tight you should actually do these screws,
because when you don't do them tight enough, the cooling will be poor and the devices might get too hot. But again, if you really overdo it, you could actually break one of the devices. I mean, they are not really hard, not really easy to break, but still you shouldn't put way too much force on them. Just a good amount to press everything together firmly. So, there you go. Now you have replaced all the relays inside the amplifier section, and you should be able to put it all back together. So this part is at least as complicated at getting the whole thing out, but you have to do it the other way around. So I will start by bringing this back to its orientation that it should have, and then try to find my way to lower this whole thing back inside the cabinet, trying not to mess up any connections, trying not to break any cables. And there you go, that actually worked out quite nice. And then you see this slot back here. This is where you would align this PCB with. So when pushing back the whole section, make sure this is aligned. And then you will already hear these 3 plastic retention pins we removed earlier here. And now when the section is seated again, you can go in there, put force on the PCB to actually re-engage these 3 pins. Now the section is already again quite firmly. You can reconnect this black connector here, just bend it in the right orientation and then push it all the way down into its slot. So now we have to redo a lot of connections. I would start by putting this board back to its place, so just turn it around and stick it through with the 6-inch connectors to the back. And then you can also put these speaker terminals back to the place where they belong, just to get them a little more out of the way right now. We will screw everything in back later. Now you remember that we also took out 1 or actually 2 boards here. We can reattach them now. So take these 2 boards in this orientation, move this cable to the left because all the connectors here have to go next to this connector. So first I would line them up at the back so that they actually penetrate where they should. Move them all the way to the back until you see the contacts down in there lining up. And then just push it down. Make sure that in the end all the connectors down here actually match up and are properly seated. Now the only thing left to do is to redo all the connections, all the wiring, and to screw the things back to the back. So in the process we removed actually a lot of connectors, trying to remember all of them here. So is this pair or triplet of cables that you would need to reseat to the front. There is this pair that has to go right here. And then there are a lot of these cables that just end up with single pins like this. So you would have to first guess or find out which is which. Unfortunately I cannot show you this very good on camera, but there's this one cable with just 3 pins that has to go all the way down to the AC input board. If you're not sure about the orientation, there will always be one lead on one of the sides which is blackened, or actually black. And on each of the sockets there will be a marking, which is actually a white marking showing you the first connector. So just align the black lead with this white marking. Push on the connector, then insert the cable and then let go. And then the cable should be in there firmly. Now you repeat this process for the 3 cables left here. And as I said, there's only always one cable that has the right amount of pins, or right number of pins. So you should be good to go there if you just watch out for the number of pins required for the connector. So now it's basically up to you how many of these cable ties you want to redo, since it doesn't really have any effect on the operation of the device. It just makes it look a little nicer if you redo them. So I'm going to leave it like that, and then now I'm going to just cut off the excess length of the cable ties. So this is about how I would leave it be. Now I'm just going to screw back all the things that I unscrewed on the back. But before I do that, I want to put the two screws back in that I removed from the cooler back here at the front of the unit. Like so. Now on the back we're going to redo all the screws along the speaker connectors, the 5-channel input and the video in and output. And before you do all these screws back in, just make sure that all the connectors are aligned. Like these S-video connectors right now, they bend a little to the side. So just make sure that when you screw them in, they're actually properly aligned. And then they will basically pull themselves into their respective slots once you tighten up the screw. Like this. This also goes for this 5-channel input board and the speaker terminal board, since these boards are right now completely free. As you can see, they move around. So just make sure that you actually line them up when screwing in. And then eventually you should be done, and you can double check that if you just have the black screws left and none of the brighter ones, because they all go to the back of the unit. So this is the end of the first part of the repair, which concerned the no sound problem. So now after you've replaced all these relays, you should have your sound back again, if this was actually your problem, which is highly likely. Now I'm going to continue with the second part of the repair, which is going to be about the rotary encoder. And this rotary encoder sits on the other side of this PCB. So the first thing you need to do is you need to turn the unit back around. And in order to actually get to that rotary encoder, what you first need to do is just firmly pull on this volume control knob. It's not glued or anything, it's just holding by friction, so just pull a little on it, it will come loose. And then you already see this screw or this nut holding in the rotary encoder. For that, just take some strong pair of pliers and then gently undo it. Once you completely undid the nut, you can take the whole PCB out to the back. Like so. And now you see the actual rotary encoder sitting on there. And this little PCB is also connected via a 3-pin cable to the main digital board. So you have to undo these 3 solder joints in order to get it out. And remember that the orientation the cables go in. So one of the cables here has a white marking and it goes right at the top of this connector. And the way I usually get this board out is just by heating 3 contacts more or less at once.
then just pulling it off like that. Now you end up with the board on its own. And once more you can get rid of the whole amplifier. Now there's a couple of things I want to do here. First I want to clean up the 3 holes for the cable. And then I of course also want to remove the whole rotary encoder. So I'm applying a good amount of fresh solder to each pin here. Then I start up by cleaning the holes for the cable. So I should now be able to reattach the cable easily later on. So now continue with the actual rotary encoder. So now we end up with the bare rotary encoder, which we can now work on further. And to actually get it apart further, you see these 4 metal clamps holding the different parts of it together. So we want to push each of these clamps a little further out, so that actually free the different layers. So be sure to be gentle here, because these metal clamps are just designed to go on once. You can make them go on a second time, but they are really fragile and not made for servicing in that kind of way. So now, after you've undone all these 4 things, you can actually take off the back plate of the rotary encoder. Now you can see inside, and you can actually take it apart even further. So you can separate this green plastic part from the metal, like so. And then you can even push the black stick out of the metal part. And now you can see everything that makes up this rotary encoder. So we have this, which is the actually rotating part. This is just the housing. And in here you see multiple contacts that are connected depending on the position of the actual shaft. So by reading out the electrical connections between these 3 pins, the CPU inside the AVR can then determine in which orientation this shaft is actually turned. So what we want to do now in order to clean it is to get all the liquid or the oil that's around it right now, to get all of that off and then replace it with a new clean oil or something lubricant like that. So first I'm going to remove all of the compound that's on that right now, just with some paper. So this is how the parts look after just the cleaning with some dry piece of paper. Now I'm going to give them another go with some isopropanol alcohol, just to get rid of every last bit of dirt that might be still in there. The only thing you need to be careful is not to bend these small pins in any direction, because they are bent in a very specific way so they make proper contact. So you don't want to bend them too far in one direction, so you just don't want to bend them in any way so that they keep the perfect pressure to make good contact. So now, after you've removed all the old lubricant, of course what you're going to need to do is you're going to have to apply some new lubricant. And what I do is I just use some random off-the-shelf multi-grease. It's usually for lubricating gears and stuff, but it's going to do the job just fine. Just make sure not to use oil or anything, because it has to be a little more sticky and a little more solid to just stay in there and to give you this soft feedback when you actually turn the thing. So I will just apply a reasonable amount to this outer housing. And then just stick the shaft back through. You can use a little too much here, it doesn't really matter since it's not conductive or anything, and it will distribute itself nicely over the whole length of the shaft by itself. So just make sure to put enough in there to keep it all nice and easy going, and then just give it some terms to actually distribute this stuff all over the place. Then apply some more amount to the actual encoder surface. Again, if it's too much, it doesn't matter, it will get off the outside. And now reattach this green actually conductive layer in a way that the 3 pins line up with the 1 pin on the metal housing, and that the springy pins actually make contact with the rotary thing inside. So the pins will point to the back of the thing. Now again, just turn it sometimes. Maybe remove the excess lubricant that's coming out at the back. But again, if it stays in there, it doesn't matter, since it's not conductive or anything. Just make sure it's nice and distributed everywhere. And if you have the feeling that it's going fine, then just take the back metal plate. The orientation of this doesn't matter. Just make sure that this metal clamps actually go around the housing of the whole thing. Then give it a little push to bring everything back together nicely. And then just rebend the metal things to the actual metal housing. A bit like so. And then try to get these metal clamps as strong as possible back on there to keep the housing from coming open again or getting loose. Just like this. Now you have the rotary encoder back in one part. Still rotating nicely. It's going to depend a little on what paste you actually put on there. It's going to feel a little different from before maybe, but it's going to do the job either way just fine. Now you can stick it back into the PCB. It will actually spring in place because of these spring contacts on the end. Then just solder it back on. It requires some heat since it has quite large surface areas on the contacts. But again, usually you should start with the contacts of the actual housing to get any mechanical stress on these pins, since they are designed for that. And then work your way down to the actual electrical connections on the other side here. And there you go. Now you have the cleaned rotary encoder reseated to the PCB. Now we have to get the amplifier back. Now you have to find a way to resolder this wire with 3 pins back to the PCB. And again, the pin with the white marking on the cable has to go to the uppermost hole. I'm going to do this off camera. And once you reattach that cable, you can now put the rotary encoder shaft back through the casing to the front of the unit. While doing so, just make sure there is a metal pin on that rotary encoder that should actually penetrate through the casing to the front like this, so you know the rotary encoder is properly orientated and won't move around. Then you can reattach the nut to it. Since they put some glue on that shaft, it's actually not that easy to screw it on, so you might actually need to use your pair of pliers to do the last turns. And you don't really need to put any force on that nut, since it's held in place nicely by this shaft down here. And now it's in. And then you can put the actual knob back on. Just make sure that there is a cutout on this shaft. Align that cutout with the cutout in the knob. And then just push it all the way in. Now you should see it's still rotating nice and smoothly. And if it had a problem before with some glitching, that problem should have disappeared by now. So now it's time to completely close up the unit again.
So now once you put the case back on and secure it with all the 7 screws on the sides, you should end up with a perfectly working receiver, as you can see now as well as before, but the rotary encoder now works fine without any glitches, and you can hear the sound clearly even at low volume. Yeah, so I hope this video was helpful for some of you. I hope some of you are now able to repair their Onkyo receivers and get some more years of use out of them. Thanks for watching.